Now turn to Section 4. Section 4. You will hear a presentation on an online course. First, you have some time to look at questions 31 to 40. Now listen carefully and answer questions 31 to 40.
Welcome to this presentation on our online course, An Introduction to Electronics, which runs over 10 weeks and starts on 8th of May. Let me just say at the beginning that if you cannot make this date, please send me an email about the next course, and I will send you a list of future dates. My email is the front of your brochures. Now, let me tell you something about the course. Based upon our popular 2-day overview of electronics course, this new online course will introduce you to the basic ideas behind electronic circuits. The course will consist of 10 units each, of which will involve around 5 hours of study. The course is designed to act both as an introductory course and as a refresher course. After taking the course, you should have a good idea of how electronic systems work and how they are made. In particular, the course focuses on the design of a hi-fi amplifier. The course is limited to analog electronics, where signals are represented by continuously variable voltages, and will not cover digital electronics, where signals are represented by discrete numbers. Students should normally have a reasonable proficiency in school maths and science. Study to GCSE level is sufficient for most of the course, though study to A level will enable a full understanding of the more advanced topics. Students on the course will be supplied with a copy of Terry Fitt's Fundamentals of Electronics. This will be used for directed reading, assignments and further study. It also serves as a useful reference source. The student should have PC available and a basic knowledge of Windows in order to use the simulation software from the CD-ROM that comes with this book. Now, who is this course designed for? This course is intended for individuals with little prior knowledge of electrical or electronic engineering who want to get a feeling for the subject, and for individuals whose knowledge is rusty or out of date. A previous exposure to basic science and maths at school will be assumed. Maximum benefit will accrue to those who have attended higher education in a technical subject, or who have experience in a related area. Typical attendees may include those in jobs which bring them into contact with electronics, such as draftspersons, PCB designers, production and assembly personnel and software designers, those working with electronic products, such as managers and salespersons, those coming into electronics from a related field, such as scientists or mathematicians, and those simply curious to find out about this all-pervasive technology. The benefits of this course are that, first, it gives you a quick insight into modern electronics. It also puts emphasis on practical devices and systems. Unlike many other courses, no prior knowledge is assumed, but previous exposure to school-level science and maths is assumed. Fourthly, it can be used as a refresher course. Fifth, there is the benefit of getting hands-on simulations, and finally, all delegates completing the course will receive a University of Oxford Certificate of Completion. The course will be presented by Brian Williams, who started his career working as an electronic engineer for British Aerospace. Brian then became a lecturer and has taught electronics at Oxford University and Jesus College for longer than he cares to admit. He is also an active consultant and researcher. Brian is a dynamic lecturer and particularly enjoys teaching introductory level courses and interacting with students. Now, finally, let me just quickly go through the course content. Please remember that this course is intended for individuals with limited prior knowledge of electrical or electronic engineering. Unit 1 looks at electronic systems, including an introduction to the idea of signals represented by voltages. Wires used to transfer signals and voltage from one place or box or component to another, and boxes or components manipulating voltages, particularly amplifying them. Unit 2 takes a look at Ohm's law, the linear relationship of voltage and current, and the concept of resistance. It also looks at resistors and resistor networks. Unit 3 focuses on op-amps, providing an introduction to the ideal op-amp and its applications. The next slide tells us that Unit 4 is concerned with capacitors and AC circuits. The theory and applications of capacitors and their use in transient and AC circuits. Unit 5 looks at frequency response and filters, including both passive and active filters. Unit 6 takes a look at magnetism, inductors and transformers. Looking at this next slide, we can see that Unit 7 covers RL and RLC circuits, including tuned filters and crossover networks. Unit 8 is entitled An Introduction to Semiconductors. It covers diodes and rectifiers, both theory and applications. This unit also looks at special purpose diodes. Unit 9 covers transistors, particularly bipolar transistors, including theory and typical circuits. The final unit, Unit 10, is a review unit with a little look at further applications.
That is the end of Section 4. You now have half a minute to check your answers. That is the end of the listening test, the IELTS test. You now have 10 minutes to transfer your answers to the listening answer sheet.